if we add a capacitor to the circuit that we see here, so that we have resistance and an inductance element and a capacitance, then our equation for the voltage drops is the same as before, except we also have voltage drop Q over C across the capacitor. Remember that capacitance C is the charge to voltage ratio. More charge, less voltage, bigger capacitance. Okay, and that's easily rearranged to see that the voltage is charge divided by capacitance. So that our equation becomes this. Now, we're not going to talk about solving this equation, although we can solve the equation setting this equal to 0 very easily using the same substitution we used before. There's really no difference except that we have an extra term here. And then, of course, if we have a constant source, it's pretty easy to solve this. If we don't have a constant source, we have to do a little work to figure out what function Q works for this. Now, where do we get the Q's? We have to use Q because the capacitance gives us voltage drop Q over C. So we're going to have a Q over C here. Now here we have an I, and here we have an I. Q is a function of time, so is the current. And it turns out that the current is just the really derivative of Q with respect to time, because the rate at which charge flows through here is the same as the rate at which charge is transferred from one plate of the capacitor to the other. And we are pretty familiar with that at this point. So instead of I, we're going to use dq dt. So Ri becomes R times dq dt, and the derivative of I with respect to t is the second derivative of Q with respect to t, and I should be putting a 2 on the t right here to emphasize that this is a second derivative. So here's our equation. Again, it's easy to solve when you put 0 here. You just get an R and you use what you get. If you have a constant EMF, it's going to be easy to deal with. If you have a sinusoidal EMF, it's not going to be difficult. And if you have anything else, we're not going to talk much about it because we aren't going to have the techniques. But just basic calculus techniques suffice if we know to use this and to use common sense when we're dealing with a source.